Okay, so 3-6, perpendiculars and distance. The distance between a point and a line is the length of a segment perpendicular to the line from the point. Okay, so we are going to, there's also a video on how, we have to construct this with a compass and straight edge. And then we also are going to do it mathematically. So there is a video from yesterday under the Monday folder, and it's called constructing a point, a line perpendicular to from a point. And so I'm going to write on here, see video. See video from yesterday, so week 7, Monday, for construction. I'm going to show you guys, but for the recording sake of this, assignment is on the distance between, from a point to a line. So the distance, find the distance from P to L. Point P to line L. So the first thing we want to do is write the equation of line L. But whatever, you have to write the equation of line L, using your knowledge. Then you're going to write the line perpendicular to line L through point P. So then we're going to write the equation of the line equation of the line perpendicular to L through point P. So once we know what the slope is of L, we take the perpendicular, which is the opposite reciprocal. Then we're going to use P, point slope form, and figure out that equation. All right, so now we have two equations with two variables. So we're going to use systems of equations to find their intersection. So we're going to use systems of equations to find the intersection of the two lines. So imagine that I have this graph here, and I have line L. So I have line L right here, and point P right here, okay? And so I have the equation to line L. I need to find the equation that's perpendicular that goes through P, right? And so now I need this intersection so that I can find the distance between that intersection and P. So find the distance between the intersection and P. And that's going to be this right here, that distance. Okay, so I'm going to do an example problem. And we're going to use a system of equations to find the intersection of the two lines. And the point P, and that's going to be this little segment right here. How long is that? Write the equation of the line. You write the equation of the line perpendicular to it through the P. You find their intersection, systems of equations, and then you find the distance between the intersection and the point P. That's how you do it. We want to find the distance between find distance between P, which is at 2, 4, and L, that contains -5, 3, and 4, -6. All right, so our first step is slope of L. All right, we're going to use these 2 points and find the slope. So I have the y's, -6 minus 3, over the x's, 4 minus 5. negative 6 minus 3 and 4 minus negative 5. So that's negative 9 over 4 plus 5, which is 9. So the slope is 1. Negative 1. All right, so we need to write the equation. So we can use point slope form, or we can do where we solve for b. So I'm going to use this equation right here. This point right here and my slope. So I have y minus negative 6 equals the slope, negative 1, times x minus 4. All right, so this becomes y plus 6 equals negative 1x, so just negative x, plus 4. And so I'm going to subtract 6 from both sides, and I have y equals negative x minus 2. So this is my equation for L. So now we need the perpendicular line to L that goes through point P at 2, 4. Okay, so our perpendicular slope is going to be the opposite reciprocal of negative 1. Well, 1 is 1 over 1. So the opposite is going to be positive 1. And then flipping it over, it's still going to be 1. Okay, so we're going to write y minus 4 equals positive 1 times x minus 2. That gives us y minus 4 equals x minus 2. And then we're going to add 4. And we get y equals x plus 2. So this is the equation of the line that is perpendicular to line L, and it goes through point 2, 4. Okay, so now we need to find out where do they intersect. They're both equal to y. So let's just use substitution and set those equal to each other. So negative x minus 2 equals x plus 2. So I'm using substitution. That's the system of equations method, just so you have it. All right, so now let's add x to both sides. So we get 2x, and we'll subtract 2 to both sides. Those cancel, and these cancel, so this is equal to negative 4. We'll divide by 2, and we get x equals negative 2. Okay, so that's the x-coordinate of my point of intersection. So now we have to substitute in this negative 2 into one of these two equations. So I'm just going to put it in the positive one so y equals negative 2 plus 2, and that is 0. So my intersection of the two lines is at negative 2, 0. And the last step is going to be to find the distance between, so 2, 4 is my P. All right, so the distance formula. So I put my x's in one parentheses and my y's in the other set of parentheses. So I have my intersection here, and my P was at 2, 4. All right, so my x's are negative 2 and 2, and my y's are 0 and 4. So this is negative 4 squared plus negative 4 squared. And remember, whenever you square, it doesn't matter if you have a negative or not, you're going to get a positive answer. Negative times negative is always positive. So 16 plus 16 is 32. And this is the square root of 32, is the distance between the 2 points. But we're going to simplify that into 4 square root of 2. So 32, 16 times 2, 4 times 4. There's a pair of 4s, and the 2 stays in, which is approximately 5.66 units. Okay, so this is how we do it. Just follow the steps. I put this graph paper on in the resources page, and you can print one out if you want. And so I'm going to plot these same points, the same problem. Okay, so I'm going to plot the same problem, okay? So P is at 2, 4. 2, 4 is right here. And then my line is at negative 5, 3, and 4, negative 6. Okay, so I need to find, this is my line L. This is between P and L. So first thing I do is I graph it, what they tell me. And then now I'm going to find the slope of this line. So I count, 3 and 6 is 9 this way. And then this way is from negative 5 to positive 4 is 9. And I went down, so that's a negative 9. So my slope is negative 1. And so when I go down 1 over 1, down 1 over 1, down 1 over 1, all the way till I would land at this point. So it is the right slope. So I got my slope of L is, M of L is negative 1. And so the perpendicular to L is positive 1. So if I go to the P, I start at my P, and I count up 1 over 1. I'm going the wrong direction. But so I can go down 1, back 1, down 1 over 1, down 1, back, down 1, back. Oh, and I land exactly on the line. So this is the point I need to find the distance from to P. I need to find the distance, the length of that blue line. And this is at negative 2, 0. That was the intersection I found when I did the system of equations. All right, so remember the good old Pythagorean theorem. This is 4, and this is 4. All right, so 4 squared plus 4 squared is c squared. 16 plus 16, 32 is c squared. So the square root of 32 is c, which is the length of my segment. And so I did a lot faster that way on the graph. But not all problems are good for graphing. Like this, our biggest numbers were negative 6. I mean, and 5, negative 5. So we could stick on the graph. But if you have numbers like 32 and 77, it's not as easy to graph. And so you have a method